Hello there, this is Welsh ASMR 82. Hey, how you doing? Noisy page, noisy book. As promised, as suggested, as an extension of looking at the Earth and maps and flags and all that jazz, which we love on this channel, I suggested the other day, why don't I do another video about space? It's sort of an extension of what we already do on this channel. So I bought myself a nice new book by Dorling Kindersley, Knowledge Encyclopedia Space. They've got loads of these books actually. I've had a little look at them on Amazon. Basically there's all ones for animals and all sorts of things. So I'm going to flick through this book. I want to focus on certain things rather than just look through the whole book. That's a very cool picture. Okay, we're going to focus on the first chapter, which is on our solar system. So it says here, the solar system. Our local neighbourhood in space is called the solar system. At its heart is the Sun, an ordinary star that is so close it floods our planet with light. Trapped in its orbit by gravity are Earth and 7 other planets, their many moons, and millions of comets and asteroids. This picture is to scale and it looks incredible. So we have the enormous Sun, our Sun, Sol, and then we have the planets. We are tiny in comparison, not just to the Sun itself but also to Jupiter, Saturn, Uranus and Neptune. Venus is slightly smaller than us. Mars is much, and Mercury is the smallest. There are moons in the solar system that are actually larger than Mercury. So this bit here says the Sun's family. The solar system is a vast disk of material, at least 3 trillion kilometers, 1.9 trillion miles across. Most of it is empty space, but scattered throughout there are countless solid objects bound to the Sun by gravity and orbiting, travelling around it, mostly in the same direction. The biggest objects are almost perfectly round and are called planets. There are 8 of them, ranging from the small rocky planet Mercury to gigantic Jupiter. The solar system also has hundreds of moons, millions of asteroids, and possibly millions or billions of comets. So I was watching a video about the orbital plane, and I was very shocked to learn that, probably due to gravity, we are very much kind of flat, which for space, which is in every direction, is kind of weird. You'd think that you'd be able to, have anything in any direction, but seemingly we are very much flat to a certain extent. There are a couple of comets that go up and down and travel that way, but all of the planets seem to follow in a very concentric sort of shape. The orbits of the planets and most asteroids around the Sun are aligned, making a flat shape known as a plane. This means they rarely bump into each other. Comets, though, can be in orbits at any angle. How orbits work. To understand how orbits work, English scientist Isaac Newton imagined cannonballs being fired into space. If a cannonball flies so fast that the curvature of its fall matches Earth's curvature, it will keep flying forever, orbiting the planet. A fast cannonball escapes Earth's gravity. A slow cannonball falls back to the ground. At the right speed, the ball keeps falling but never lands. So this is true. The International Space Station is technically falling, but because it's falling at a certain speed, it'll never actually fall. That's why there's no gravity, because technically they're falling, and so, the gravity doesn't work. But they're just, falling so fast that they just go around the Earth rather than down into it. Minor bodies. Besides the planets, there are so many other bodies in the solar system that astronomers have not been able to identify them all. Bodies more than 200 kilometers or 125 miles or so wide, such as dwarf planets and large moons, are round. Smaller objects are lumpy in shape. So asteroids, there are millions of these rocky lumps, most of which circle the Sun, in an area between Mars and Jupiter, the asteroid belt. A few asteroids have orbits that take them perilously close to Earth or other planets. Comets. Comets are icy bodies that travel in from the outer solar system, forming bright tails as they come close enough to the Sun for the ice to evaporate. Many comets are thought to come from a vast cloud called the Oort cloud, far beyond the planets. Dwarf planets, the force of gravity pulls large objects into a spherical shape over time. Dwarf planets have enough gravity to become spherical, but not enough to sweep the area around their orbits clear of other objects. The total number of dwarf planets is unknown. And lastly, moons. Most of the planets and many of the other objects in the solar system have moons, natural satellites that orbit them in the same way that the planets orbit the Sun. 19 of these moons are large enough to be round, and 2 of them are larger than the planet Mercury. Technically, the only thing that stops moons being planets is the fact that they don't orbit the Sun, they orbit the planet. And so that's where the distinction lies. So basically there are some, we'll have a look at some in a second, Io for example, and Titan, that are so enormous they could be planets, but because they don't orbit the Sun, they orbit Saturn, Jupiter, etc., then they are classified as moons. But they can still have an orbit, they can still have an atmosphere, which makes them more like a planet than anything else, but it's just a word that's for a body in space that orbits not the Sun, but something else like a planet. And I think that's why Pluto is not classed as a planet any longer, because its moon is almost as large as it, and they sort of orbit each other rather than orbit the Sun, and therefore it's a moon of a moon. So therefore it's called a dwarf planet. So, structure. The solar system has no clear outer edge and is so big that distances are measured not in kilometers but in astronomical units, or AU. 1 astronomical unit is the average distance from the Earth to the Sun. The inner solar system, this part here. Circling nearest to the Sun are the 4 inner planets: Mercury, Venus, Earth and Mars. Beyond Mars lies the asteroid belt, this brown thing here. And beyond the asteroid belt is Jupiter, orbits in orange, which is 5 astronomical units from the Sun. Then the outer solar system, beyond the orbits of Jupiter, Saturn, Uranus and Neptune, is a ring of icy bodies known as the Kuiper belt. Some 30 to 50 astronomical units from the Sun. 2 of the largest objects in the Kuiper belt are Pluto, orbits in purple, and Aries, orbit in red. Beyond Pluto, one of the most distant solar system objects known is Sedna, a minor body whose elongated orbit takes it as far from the Sun as 937 AU. Sedna's journey around the Sun takes 11,400 years to complete. The Sun would look so tiny from Sedna that you could blot it out with a pin. And then lastly, the Oort cloud. Far beyond Sedna's orbit is the Oort cloud, a vast ball of icy bodies possibly reaching 100,000 AU from the Sun. Some comets are thought to come from the Oort cloud. The Sun's gravity is so weak here that objects in the cloud can be dislodged by the gravity of other stars. So, some fun facts about our solar system. We have the inner planets here. The inner planets are made of rock and iron and are called terrestrial planets. They are small and very fast moving. Even Mars's orbit takes less than 2 years to complete. The Sun lies in the centre of the solar system. It spins on its axis, taking less than 25 days to turn right around, despite its massive size. Venus spins in the opposite direction to the other planets. And then we have Saturn. Rings of ice or dust encircle Saturn and the other giant planets. Jupiter spins around faster than any other planet, completing one rotation in under 10 hours. The speed of the surface layer at its equator is 43,000 kph, kilometers per hour, or 27,000 miles per hour. That's incredible. Uranus, like the other planets, spins on its side, or unlike the other planets, spins on its side, rolling round on its orbit. The outer planets are all much bigger than the inner planets. They are made mostly of liquid over a rocky core. This liquid merges gradually into an atmosphere of gas on the outside. So that's the Sun. This is worth noting, the speed of light. Travelling at the speed of light, it takes a mere 8 minutes for the Sun's energy to travel across space to reach Earth. However, it can take up to 100,000 years for energy to travel through the star's intense interior to reach its surface. So the course there, it could take 100,000 years to get the energy out, but once it's out, it takes 8 minutes to reach the Earth. And because we can only see things at the speed of light, if something were to happen to the Sun, we wouldn't even see it for 8 minutes. It wouldn't be instantaneous. So when you look up at the Sun tomorrow or today, you need to realize that that's what it looked like 8 minutes ago. And that was a video I watched quite recently that made me think a lot about doing a video for this channel, saying that when we look at stars in the sky, that's what they looked like millions of years ago, and they might not even be there any longer. But that's how long it's taken the light from that moment 8 million years ago to reach us. Okay, there's some really nice ones about the planets. I want to skip these though. I want to look today at some of the big moons. They're really interesting, Saturn and Jupiter's largest moons, because there's a possibility that they could harbour some sort of basic life. There's Jupiter, our big brother. Both saves us from a lot of asteroids, but also unfortunately directs some towards us as well. The rain comes heavily down outside, can you hear that? That's a Welsh winter for you there. Okay, here we are, the moons of Jupiter. So we have Io, Europa, and Ganymede, which are the three ones I want to focus on. We also have Callisto, Amalthea, Thebe, Metis, Adastria. So Europa's icy surface is covered in strange grooves and cracks. Just as Earth's crust of rock is broken into colliding fragments, so Europa's crust of ice is broken into sheets that push and pull in opposite directions. Water from a salty ocean deep underground erupts from the cracks and freezes, creating new ground. We believe that there's a possibility that underneath the ice is just a vast ocean world with possibly heat from geysers or sort of underground volcanoes in the ocean. And the reason it's hot is not because of having a core like Earth does, but because Jupiter bends it and creates friction, and then heat explodes within. So there's a possibility, because there's water, and we suspect the other essential element of life, it's possible that we could find some ice, find some life, under the ice. Io is caught in a tug-of-war between the gravity of Jupiter and the other Galilean moons. Io is torn by powerful forces that have melted its insides. Molten rock, rich in colourful sulfur chemicals, erupts all over its surface from giant volcanoes. Ganymede. This large moon is nearly 10% wider than Mercury, and would be called a planet if it orbited the Sun rather than Jupiter. Its surface is a jigsaw of ancient dark areas with lots of craters, and younger, paler areas with few craters. Eruptions of slushy ice from underground have resurfaced the younger areas. And Callisto, the solar system's most heavily cratered object. Callisto is peppered with meteorite scars. The large number of craters shows that its surface is very old. Oddly, there are very few small craters on Callisto. Scientists think small craters gradually fade away as the ice in their rims evaporates into space, leaving small hills. So Jupiter, as a giant planet, has trapped at least 70 tiny moons to add to its original 8. These small moons were originally asteroids or comets, but they flew close enough to Jupiter to be captured into orbit by its gravity. The original 8 moons are large, and 4 of them are like small planets. We can actually see to scale. We have Ganymede, Callisto, Io, and Europa, and then the others are all much, much, much smaller. For the outer moons, we've got this diagram. Jupiter's many outer moons are only a few kilometers wide and orbit the planet in a messy cloud. The inner moons travel in the same direction as Jupiter's rotation, and their circular orbits line up neatly with Jupiter's equator. In contrast, the outer moons orbit in both directions, and their orbits are often wildly tilted or oval. This pattern suggests that most of them are captured objects. This is Io, the most volcanically active body in the solar system. Jupiter's moon Io is constantly spewing matter into space from its eruptions. Its blotchy, lava-covered face is a world away from the icy terrain of Jupiter's other moons. In fact, Io is slightly larger than our moon. And then we have Saturn, considered very beautiful for its rings. Saturn is tilted on its axis, so our view of the rings from Earth changes as Saturn orbits the Sun. When the rings are side-on in 2010, they are almost invisible. It takes around 15 years for the rings to go from full view to almost invisible and back again. These are what Saturn's rings probably look like, with the rock and dust and ice. A comet or asteroid hit Saturn's D ring in 1983, causing wobbles in the ring material that lasted for over 30 years. And this diagram shows us the ABCD rings. So the anchor gap between the A ring and Cassini division, then the B ring, which is quite large, and the C ring. Oh wow. Shepherd moons. Some of Saturn's moons orbit the planet within the rings. The gravity of these shepherd moons sweeps their orbits clear, herding the icy debris elsewhere. Saturn's moon Daphnis, above, also kicks up waves in the rings as it hurtles around the planet. Saturn's breathtaking rings are made of billions of sparkling fragments of ice that range from small grains to chunks the size of a bus. And then we have the moons of Saturn. So, one such as Titan, which is the one that interests us. This is Saturn's largest moon, and the second largest moon in the solar system. It has a thick, hazy atmosphere that hides the surface from view. Then Rhea, Saturn's second largest moon, has an icy surface with intriguing discoloured patches around the equator, which suggest it may once have had rings. peculiar moon has so many deep craters that it looks like a bath sponge. It tumbles as it flies through space, its axis of rotation wobbling, due largely to the pull of gravity from Titan. Measurements show that Hyperion is partly empty. Large hollows must exist under its surface. And here we can see the orbit of the moons of Saturn. Far from Saturn are dozens of small moons in tilted, non-circular orbits. Many of these orbit in the opposite direction to the main moons. This suggests they formed elsewhere and were captured by Saturn's gravity. And then we have the scale model. So we have very large Titan, Rhea, Iapetus, Theone, and Tethys. Enceladus is next, and then all the rest. So this is Titan. Saturn's largest moon, Titan, has some tantalizing similarities with Earth. It has nitrogen-rich air, cloudy skies, mountains, rivers, and lakes. However, this chilly world is far too cold for life as we know it. Polar lakes on Earth, clouds, rain, and lakes are made of water. On Titan, they are made of chemicals called ethane and methane. Both are invisible gases on Earth, but Titan is so cold that they turn into a liquid. They form droplets in the air that fall as rain, feeding lakes near the North Pole, like the one in this artist's impression. And then it goes on to the other planets. If you'd like to see more of this book, then let me know in the comment section. We can take a look at maybe Neptune, Uranus, Mars, and Venus. Do let me know with a comment if you enjoyed this video, and leave a like, of course. And if you're new to the channel, click subscribe. I've got a couple of older videos on the solar system. I'll put one here in just a moment, so click on that next. Big thank you to all my Patreons. Thanks to those that joined in the last month. Welcome aboard. Extra videos for anyone who watches and supports me via Patreon. So consider joining up, and thank you very much for watching the video. I hope you're nice and relaxed, and at the same time you have learned something new, which is the aim of this ASMR channel. Thank you so much for watching. Take care everyone, and